Welcome wherever you are. My name is Teacher David. Let me take you through this practical chemistry paper 3 for your revision Kcse 2026. We are required to determine what of crystallization. You are provided with solution B10, solution B14, and solution P14. P10 is hydrated sodium carbonate, given us Na2 carbonate, X water. So we are going to look for this X. We are looking for this X. Prepared by dissolving 9.536 grams of hydrated sodium carbonate in water and making it to 500 centimeters cube. P14 is 0.1667 molar HCl. Now we have all the information that we are required to know. So first, I want to tell you, whenever you are given molarity of a solution, molarity, it means the number of moles in a liter. So capital M, it means that 0.1667 capital M. Capital M means molarity. So this means it's the number of moles in a liter. So this means these are the number of moles in 1000 centimeters cube. That is what basically it means. Another thing you need to understand here, because it is important for you to understand, this solution sodium carbonate hydrated is prepared by dissolving 9.536 and the solution was made to 500. That is very important. This mass is in 500. Put that one in your mind. Let's go to the procedure. Place 25 centimeters cube of solution P10, which is now the carbonate, in a beaker. Add 2 to 3 drops of the indicator. Place solution 14, P14, in the burette and titrate. So we are now reacting a carbonate and an acid. You see that? Very important. So it is important that you know that it is a carbonate reacting with an acid. So the table has been filled for us, and I will always encourage you, if you want to use 2 decimal places like this one, you can see it is consistent and it is perfectly well. But always, I will always insist that you use 1 decimal place. 1 decimal place to avoid errors. But it is, if you can be able to consistently use 2 decimal places, good and well. Now look at the volume: 19.9, 20.1, 20. So the range of this value and this value and this value, for you to do average with it, the average with it should be between plus or minus 0.2. So if it is beyond, don't use it. If it doesn't range between plus or minus 0.2, then don't use it in average. Now since this one, all of them are within, now what we do, we can get the average. Average is 19.9 plus 20.1 plus 20.0. You divide by 3. You just put them like that. Then you find it is equal to 60 divided by 3. And the answer is 20.00 centimeters cube. Because they usually insist that the average should be in 2 decimal places. Calculate the number of moles of P14. Now P14, you come back and see what you are provided with. We were provided with that P14 is 0.166 molar HCl. So P14 is HCl. So that one is direct. We will simply ask 0.1667 capital M. I have told you this means moles in 1000 centimeters cube of that solution. So what amount of P14 did we use? You come here back to the procedure and understand where the P14 was. So P14 was in the burette. P was put in the burette. So the average volume we have here is for the P14. Therefore, we will ask if 1,000 contains these moles, what about 20 centimeters cube will contain how many moles? Because now the one that we used has got the volume for the solution of P14 used is 20 centimeters cube. So this times this, that is 20 times 0.1667, you divide by 1,000. And this one gives you the answer as 0.00334 moles. You can also give to 4 significant figures, it is okay. The next question is, write the equation for the reaction that is taking place. Now that is very important. It is you to know that this is a carbonate reacting with an acid. You must know that when a carbonate is reacting with an acid, what does it give? Metal carbonates react with acids to produce 3 things: salt, water, and carbon 4 oxide gas. Very important. If you don't know that, it means you will not write this equation, you will not balance the equation. So we have now the B10, which is the carbonate. The reaction was between the carbonate, that is sodium carbonate, plus, which has got the water of crystallization, so you can leave that one out, plus HCl. This one was able to give us sodium chloride plus CO2 plus water. So sodium here has got 2, so it means we have to put sodium 2 here to balance the equation. The chloride now are 2, you need to put 2 here, and the equation is balanced. Now once you have balanced that, you come down. The mole ratio, you can see that 1 mole of the sodium carbonate, this with this water, there's no problem if you put that X here, water, it does not affect anything. If you put this one here, it doesn't affect anything, this X water. So this carbonate reacted with this in the ratio 1 to 2. So the ratio between the carbonate and the HCl is 1 to 2. As you can see, that one is important in the next step. Calculate the number of moles of sodium carbonate in 25 centimeters cube. Remember, the carbonate we pipetted. Place 25 of solution 10. P10 is our carbonate. So we used 25, so we know this one is 25 centimeters cube. That one is perfectly well known. Now, what is the number of moles of the carbonate? We already know the number of moles of HCl. So the number of moles of this HCl is 0.00334, right? So since 25 centimeters cube, actually this is 25 centimeters cube reacted with 20 centimeters cube HCl, and the number of moles of this one is this. So the number of moles of the carbonate will be a half because the ratio is 1 to 2. So you simply say here 2, which is the ratio for the HCl, has got 0.003334 moles. Right? Now you simply ask 1, which is for the sodium carbonate, 25 centimeters cube, will contain how many moles? You will see that it is 1 times this divided by this. It is simply a half times 0.00334 moles, and that one gives us the moles of the carbonate. So the moles of the carbonate will be equal to a half of the number of moles of the HCl, because the ratio is 1 to 2. 0.01667 moles. This is the number of moles of the carbonate that reacted with HCl. Calculate the molarity of the sodium carbonate solution. The molarity of the sodium carbonate solution. Remember, molarity, the other way you could have been asked, you will be told calculate the number of moles in grams per liter. Grams, the number of moles in grams per liter. So if you are told, not grams, calculate the number of moles per liter. Calculate the number of moles per liter. Moles per liter means molarity. Moles per liter means molarity. And the molarity, it is important to understand the definition, is the number of moles of a solution in a liter. A liter is equal to 1,000 centimeters cube. When you have this knowledge, everything becomes very simple. We have the number of moles of the sodium carbonate in 25. So 25, the one we calculated in part D. Part D, we have the number of moles of the carbonate in 25. This is the number of moles in 25. So we will ask, what about 1,000 centimeters? Because 1,000 is equal to a liter. So 25 centimeters cube of the carbonate solution B14, was it B14? No, P10 is equal to 0.001667 moles, the one we calculated in part P. So we simply ask a liter. Molarity is the moles in a liter, so we would simply ask 1,000 centimeters cube will be how many moles? So it is 1,000 times 0.001667. You divide by 25, and that one gives you the number of moles in a liter. That one is equal to 0.06668 capital M. Just give it. So if you don't let capital M, that is, we know what the question was asking, it was molarity. You can give it capital M or moles per liter. Moles per liter, it is allowed. Or mole per dm cube. Still, that is the correct unit, because a 1 dm cube is equal to 1 liter. Calculate the number of moles in 500 centimeters cube solution sodium carbonate. Now that is simple, because now we know the number of moles in a liter. Well, a liter is 1,000, so 500 will not be a difficult thing. So 1,000 centimeters cube of the carbonate of B10, that is the carbonate, has got which number of moles? 0.06668 moles. Yes. Now, is it difficult for us to get the moles in 500 of the same solution? Not at all. Very simple. So that is 500 times 0.06668. It is a half of the number of moles there. So the number of moles will be 0.03334. Or if you want to use the formula, you can use this one, or we have this formula for those who like using formulas. We have the formula that says molarity, moles, then volume in liters. Volume in liters. So if we are looking for the number of moles in 500. So our volume is 500, and we will convert it to a liter, and we will be able to get. So molarity, we have moles. We are looking for that moles. So we have the volume. So moles would be equal to molarity, which is this one, 0.06668 times the volume, which is 500. Now convert the 500 into a liter, and that one will give you exactly 0.03334 moles. It will give you exactly. If you use the formula, you will still get. Calculate the RFM, the relative formula mass of the hydrated carbonate, RFM. Now, for you to calculate the RFM, it is important you understand this triangle again. We have three triangles, very important three triangles in moles. One is this one, the second one I'm giving you, and the other one is the obvious, the one which is in Kelvin. So these two are not in Kelvin. So this one we have molarity is equal to mass. We have mass in grams per liter. This mass must be in grams per liter. And then we have RFM. So we are looking for the RFM. To get RFM, you must have mass in grams per liter of whatever solid is that, divided by its molarity. Now, we are looking for the RFM of hydrated sodium carbonate. But remember that the reason why I asked you to keep this thing in mind. I told you to keep this mass in 500 in mind. So this mass, we have reached where we need mass. But the mass we are given is in 500. But the mass we want to use must be in a liter. So you will ask, if 500 centimeters cube contains this, 1,000, because which is a liter, it will be how many grams? That is simple. Very important to understand that. Now you say that 500 centimeters cube was prepared from 9.536 grams. We need mass in grams per liter. So we need a liter. A liter is 1,000 centimeters cube. We will find out how much is that. Actually, it is twice. So it is going to be 18 point something or 19. So that is 1,000 times 9.536. You divide by 500. And the answer is going to be 19.072 grams per liter. Now we have mass in grams per liter. Once you have that mass in grams per liter, apply now the formula. We are looking for the RFM. So RFM is equal to mass in grams per liter, this one, divided by molarity. Where is the molarity of the sodium carbonate? The sodium carbonate hydrated, we calculated here. Molarity is here. Molarity is here. So now RFM is equal to mass in grams per liter divided by molarity. And that one is equal to mass in grams per liter, 19.072 divided by molarity, which is 0.06668. And you finally get the molarity as 286.0 grams. That is now the RFM, sorry. The RFM is 286. We have now the RFM. Alright. The next thing is to determine the value of X in the salt. To determine the value of X in the salt. So when you add the RAM of sodium, of the carbonate, of the oxygen, of the water, you will get the total. This one, that one will give you the total. So it means that sodium carbonate X water, when you add everything, the answer should be 286 grams. Now here you will be given that sodium is equal to 23. You will be given that H is equal to 1, C equal to 12, O is equal to 16. You will be given this information and it will help you to calculate this. So you will start by sodium. Sodium is 23. there are two of them times 2 plus carbon, which is 12, plus 16 times 3, this one, then plus X water, this one is a combined, so that is X is water is 18. 18 how? This is 16 plus 2, 18. 18 times X, itakuwa 18X is equal to 286. Now bring this one, this is 46 plus this 48. You will find that the total there will be 106 plus 18X is equal to 286. Like terms together, bring this to this side and subtract. 18X will be equal to 108. Now we will need the value of X. You divide by both sides by 18 by 18, and the value of X is equal to 10. Then the next question we will be asked is to write the carbonate salt in full. So you are going to substitute X with water with 10. So we will have the salt name is sodium decahydrate. Instead of X, now we will have this sodium carbonate 10 water. You are provided with solid N. Carry out the test below. Write your observations and inferences in the spaces provided. Heat about a half of solid N in a clean dry test tube. Heat gently, then strongly. Test N gas produced using moist, blue, and red litmus paper. That is a common test. You need to ignore observation that is expected. A colorless liquid is formed. It is always expected that a colorless liquid is going to be formed at the cooler parts of the test tube. Do not say water is formed. Who told you this water? Don't say the test tube sweats. If that is not chemistry. So simply master this, that a colorless liquid is formed. That is what we expect. What happens to the blue litmus paper? It is either the blue litmus paper will change to red or it will remain blue. Red will change to blue or it will remain. So in this case, so it depends the salt provided. Blue litmus paper changes to red while red remains red. So what is that changes blue litmus paper to red? Then it must be that the gas that was produced is acidic, because blue litmus paper changes to red in acidic solution. So for this one, you write, if it contains what this one, a colorless liquid is formed, then it means it contains water of crystallization. Just say hydrated salt in the inference. Hydrated substance or salt. Hydrated substance present. Or you can simply say solid N is hydrated. Solid N is hydrated or contains water of crystallization. Solid N contains water of crystallization. Contains water of crystallization. On the blue litmus paper turning red or changing to red, it means it contains hydrogen ions present. Hydrogen ions present. Take a spatula end of N in a test tube and add distilled water until a half filled. Shake, divide the solution into 5 portions. So the solid dissolves, forming a colorless solution. So if a colorless solution is formed, then it means the colored ions are absent, because those that dissolve to form a colorless solution are very many. So we write what is absent. So for this one, copper 2 ions is absent because this one is blue. Ion 2 is absent. Why? Because this one is green. And ion 3 is absent because it is brown, absent. So you write this absent because it is colorless. This is blue, green, brown. To this first portion, add 2 molar sodium hydroxide solution, drop white until in excess. The observation are a white precipitate is formed, which dissolve in excess sodium hydroxide to form a colorless solution. So sodium hydroxide will dissolve in the amphoteric ions only. So the amphoteric ions, we have them, we call them ZAP. ZAP stands for zinc, aluminium, and lead. These are the amphoteric ions. Therefore, sodium hydroxide dissolve here only to form a colorless solution in excess. So there you write zinc, standing for ZAP, Z, aluminium, 3 positive, and then lead. So these ones are present. The word present and absent is very important in this case. To the second portion, add 2 molar ammonium hydroxide or ammonia solution. A white precipitate is formed which dissolve in excess. If it dissolves in excess to form a colorless solution, then it means what is present is zinc. So due to this observation, then the zinc 2 ions are present or confirmed, meaning aluminium and lead are absent. To the third portion, add 3 drops of 2 molar HCl. So if you add HCl and lead was inside there, it will form a white precipitate, which is lead chloride. Lead chloride is a white precipitate. Now, since there is no white PPT, it means lead is absent because HCl, Cl will combine, was expected to combine with lead. But now that there is no white precipitate, it means it is absent. So for inference, you just write lead 2 ions absent, because already we have confirmed what is present. To the fourth portion, add about 1 centimeters cube of 2 molar lead nitrate. Lead, a white PPT is formed. So lead forms a white precipitate with the carbonate, so that we have lead carbonate, because we know all carbonates are insoluble, are white precipitate except that of potassium, sodium, and ammonium. It will also form a white precipitate with a sulfate, because we know lead sulfate is a white precipitate, a sulfite, and a chloride, because lead chloride is a white precipitate. All chlorides are soluble except lead chloride and silver chloride. So from that, because a white PPT is formed, it means the sulfate, the sulfite, the carbonate, and the chloride are present. That is what it means. To the fifth portion, add 1 centimeter of 2 molar barium nitrate followed by dilute nitric acid. Now this one is supposed to help us to distinguish, to eliminate some of the anions present. A white PPT is formed which is insoluble in the acid. If a white precipitate is formed, if you add nitric acid, it dissolves to form a colorless solution. It means it is the sulfite and the carbonate present. But if you add barium, it forms a white PPT. Then in addition, when you add dilute nitric acid or HCl and the acid, when you add the acid, the white precipitate persists. It means what is there is the sulfate. So you say S. O4 2 minus confirmed or present. You can say present or confirmed. That is what is there. Thank you.